This is the EdExcel Advanced Extension Award from the 2020 series. Question number 1. We have figure 1 over here, which shows a sketch of the curve with equation y equals f of x, where f of x is given by 1 plus 4 over x multiplied by x subtract 3. The curve has a turning point at the point P, that's what we see here, and the lines with equations y equals 1, x equals 0, and x equals a are asymptotes to the curve. And for part A we have to write down the value of a. Well, if we take a look at the 1 plus 4 over x multiplied by x subtract 3, then we notice here we cannot divide by 0, so x cannot equal 0 and x cannot equal 3, otherwise we will be dividing by 0. X equals 3 is the equation of the asymptote, and so therefore a is equal to 3. For part B of the question, we have to find the coordinates of P, justifying our answer. Now, what we know already is we have a turning point at the point P. That would suggest to us we would have to differentiate f of x and set that equal to 0, from which we can find the coordinates of the turning point. Now, we can rewrite f of x as 1 plus 4 over x squared subtract 3x. And this form here would allow us to differentiate easily. F dash of x is equal to, well, differentiating the 1, we end up with 0. And now to differentiate 4 over x squared minus 3x, we would have to use the quotient rule. So we have x squared subtract 3x multiplied by the derivative of 4, which is 0, subtract 4 multiplied by the derivative of x squared subtract 3x, which is 2x subtract 3, and then we would divide this by x squared subtract 3x all squared. So now let's try to simplify this. Well, 0 times x squared subtract 3x is 0, and so on the top we have negative 4 multiplied by 2x subtract 3, and then we divide this by x squared subtract 3x squared. And now that we know what f dash of x is, if we set f dash of x equal to 0, what we can do from that is find the x coordinate of the turning point. So we have negative 4 multiplied by 2x subtract 3 over x squared subtract 3x all squared equals 0. So we have 2x subtract 3 equaling 0, and from this we can see x is equal to 3 over 2. So the x coordinate of the turning point is equal to 3 over 2. From this we can find out what the corresponding y coordinate is. We can do that by substituting x equals 3 over 2 back into f of x. So f of 3 over 2, that's equal to 1 plus 4 over 3 over 2 squared, subtract 3 multiplied by 3 over 2. So now let's try to simplify this. We have 1 plus 4 over, well here 3 over 2 all squared is 9 over 4, and then we have negative 3 multiplied by 3, so that's negative 9, and then we divide this by 2. Now negative 9 over 2, that's the same as negative 18 over 4. If we write these over a common denominator, it makes it easier to work out this calculation. So we have 1 plus, well, here we have 4 over negative 9 over 4, so that will be the same as 1 subtract 16 over 9, which is the same as negative 7 over 9. So the coordinates of P, we have 3 over 2, negative 7 over 9. Here is the coordinates of P. For part C of the question, we have to sketch the curve with the equation y equals the mod of f of x plus 3 over 2 subtract 1. On your sketch, you should show the coordinates of any points of intersection with the coordinate axis, the coordinates of any turning points, and the equations of any asymptotes. Here we can see the graph of y equals f of x. We have our asymptotes, which have equations y equals 1, x equals 0, and x equals 3. And we've got our turning point, which has coordinates. Well, we have 3 over 2 and negative 7 over 9, as we see over here. So what we now have over here is the graph of y equals f of x plus 3 over 2. We have shifted the x coordinates 3 over 2 units to the left, and the result of doing so, our asymptotes will move 3 over 2 units to the left. So here we have x equals negative 3 over 2, and here we have x equals positive 3 over 2. And the turning point will now lie on the y-axis. The turning point would have coordinates 0 and negative 7 over 9. and our horizontal asymptote y equals 1 remains the same. Now, if we mod this graph, we reflect it in the x-axis, and so here we have the graph of y equals the mod of f of x plus 3 over 2 and so our horizontal asymptote stays at y equals 1. Here we have x equals negative 3 over 2, and here we have x equals 3 over 2. The turning point will lie here. The x coordinate is 0, but for the y coordinate we would have positive 7 over 9. So here is the graph of y equals the mod of f of x plus 3 over 2. But now what we need to do is shift this graph 1 unit down. And here is the result of that. So our asymptotes, we have x equals negative 3 over 2, and here we have x equals positive 3 over 2. We've moved our asymptote here 1 unit down, so we've got an asymptote at y equals 0, and our turning point has been moved 1 unit down. So if we do 7 over 9 subtract 1, we get negative 2 over 9. So here we've got 0 and then negative 2 over 9. So we've got the graph of y equals the mod of f of x plus 3 over 2 subtract 1. Now what we need to do is find out where the graph intersects the x-axis, and we can do this first of all by setting y equal to 0. Now before that, let's work out what f of x plus 3 over 2 is. So if we first of all work out what f of x plus 3 over 2 is, then we have 1 plus 4 over, now we would have x being replaced by x plus 3 over 2. So we have x plus 3 over 2. So let's rewrite this. And then we have x plus 3 over 2 subtract 3. And so simplifying, we would have 1 plus and then 4 over x plus 3 over 2 multiplied by x subtract 3 over 2. So if we now replace y with 0 and then solve this equation, what we would have then is the modulus of 1 plus 4 over x plus 3 over 2 multiplied by x subtract 3 over 2 subtract 1 equals 0. And so, if we now attempt to solve this equation, we have 1 plus 4 over x plus 3 over 2 multiplied by x minus 3 over 2 equals plus minus 1. And then if we deal with the positive solution, we would have 1 plus 4 over x plus 3 over 2 multiplied by x minus 3 over 2 equals 1. Now, these cancel out. So we have 4 over x plus 3 over 2 multiplied by x minus 3 over 2 equals 0. And here we have no solutions. And now if we deal with the negative, we have 1 plus 4 over x plus 3 over 2 multiplied by x minus 3 over 2 equals negative 1. And if we rearrange, we have x plus 3 over 2 multiplied by x minus 3 over 2 equals minus 2. So x squared subtract 9 over 4 equals negative 2. For x squared subtract 9 equals negative 8. 4x squared is equal to 1. X squared is equal to 1 over 4. And therefore x is equal to plus minus 1 half. The graph of y equals the mod of f of x plus 3 over 2 modded plus 1 intersects the x-axis at plus minus a half 0. And that's what we see over here. So here is our required graph. Question number 2. The functions f and g are defined by f of x equals 2 multiplied by 1 minus e to the negative x square rooted, where x is a real number and x is greater or equal to 0, and g of x is equal to the natural log of 4 subtract x squared, where x is a real number and x is in between minus 2 and 2. Now for the first part of part A, we have to explain why f of g cannot be formed as a composite function. So for part A, we've got f of x, which is equal to 2 multiplied by the square root of 1 minus e to the minus x. And if we think about the domain, well, we know x is a real number and we know that x is greater or equal to 0. So with this, let's think about how we would find the range. So for the range, well, when x is 0, f of 0 is equal to 0. And if we think about what happens as x gets really large, Well, as x tends towards infinity then, e to the negative x tends towards 0, which means f of x would tend towards 2. So for the range, we have 0, which is less than or equal to f of x, which is less than 2. And now when we come to sketch a graph, here is the graph of f of x. So now let's think about g of x. We know g of x is equal to the natural log of 4 subtract x squared. For the domain, x is a real number between -2 and 2. For the range, well, let's think about different values of x. When x is -1, say, we have the natural log of 3. When x is 0, we've got the natural log of 4. When x is 1, we've got the natural log of 3. So I'm going to expect the graph to look something like this. So this maximum point, essentially, we can find by thinking about what happens when x is 0. So when x is 0, g of 0 is equal to the natural log of 4. And here we've got asymptotes x equals -2, x equals 2. And then if here is our x and y axis, for our range, we would have minus infinity, which is less than g of x, which is less than or equal to the natural log of 4. So if you think about a sketch, our graph will look something like this. So for the first part of part A, if we take a look at the range of g and the domain of f, well, what we're going to be doing is substituting in something from g into f. Now, with the domain of f, we are saying x is greater or equal to 0. But from here, we are saying that we can substitute in values from -infinity to the natural log of 4. So the problem here is the range of g does not lie in the domain of f, which means f of g cannot be formed. Now, for the next part, we have to explain why g of f can be formed as a composite function. Now, if we take a look at the range of f, which is from 0 up to 2, and if we look at the domain of g, which is between -2 and 2, we can substitute in any value between 0 and 2 into g, which means the range of f lies in the domain of g, so g of f can be formed. For part B of the question, we have to find g of f of x, giving the answer in the form g of f of x equals a plus bx, where a and b are constants. So for part B, we want to find g of f of x, which means we need to replace x with the function f. So we have the natural log of, and open brackets, or subtract the function f, which is 2 times by 1 subtract e to the negative x square rooted squared. So if we simplify this, we have the natural log of, here we have 4, subtract, now here 2 squared is 4, and then square root of 1 minus e to the minus x squared is 1 minus e to the negative x. So we have the natural log of 4 subtract 4 plus 4e to the negative x, which would simplify to the natural log of 4e to the negative x. And if we use the addition law of logs, we've got the natural log of 4 plus the natural log of e to the negative x. So we've got the natural log of 4 subtract x times the natural log of e, and the natural log of e is just 1. So we end up with the natural log of 4 subtract x. And if we think about what the domain is going to be, well, x must take a real number, but if we take a look at how f is restricted, we know x must be greater or equal to 0, which means for the domain of g of f of x, x must also be greater or equal to 0. And for the range, now what we have is a straight line graph, so it looks something like this. When x is 0, here we've got the natural log of 4. We don't want values of x which are negative, and the graph goes from the natural log of 4 down to negative infinity. So for the range, we've got negative infinity, which is less than g of f of x, which is less than or equal to the natural log of 4. Now for part C, we have to sketch the graph of the function g of f, and on our sketch you should show the coordinates of any points where the graph meets or crosses the coordinate axis. So here we've got the graph of g of f of x, and what we can see, it crosses the y-axis at the point 0 natural log 4, and it crosses the x-axis at the point natural log 4, 0. For part D of the question, the circle C with centre 0 minus natural log 9 touches the line with the equation y equals g of f of x at precisely 1 point. We have to find an equation of the circle C. Now here is a sketch of the circle and the line, and the line and the circle meet at exactly 1 point, P, say. And what we need to do is find the equation of the circle. Well, we know the centre, but what we do not know is the radius r. So we need to somehow find out what r is. So we've got our equation of the straight line, y equals natural log 4 subtract x, we'll call this equation 1, and we've got our circle, it will have equation x squared plus y plus natural log 9 squared equals r squared. We'll call this equation 2. notice the centre is 0 minus natural log 9. Now, what we will do is we will replace the y with natural log 4 subtract natural log x. In other words, we will substitute in equation 1 into equation 2. So we have x squared plus natural log 4 subtract x plus natural log 9 squared equals r squared. So we have x squared plus natural log of 4 times 9, which is 36, subtract x squared equals r squared. So if we expand this out, well, we've got the x squared, and then expanding natural log 36 subtract x all squared, we end up with natural log 36 squared subtract 2 times natural log of 36 plus x squared. This is equal to r squared. So therefore, we have 2x squared subtract, here we needed an x, 2 times the natural log of 36 x plus natural log of 36 squared subtract r squared equals 0. And we can find out what r squared is by using the discriminant. We can use the fact that b squared minus 4ac is equal to 0 because the line and the circle touch once. So we have minus 2 times the natural log of 36 squared minus 4 times 2 times by, well, here we have natural log of 36 squared minus r squared equals 0. So minus 2 times the natural log of 36 all squared, that will equal 4 times the natural log of 36 squared. Then we subtract 8 times by the natural log of 36 squared. Negative 4 times 2 times negative r squared, that's positive 8r squared. This is all equal to 0. So 8r squared is equal to 4 times by the natural log of 36 squared, which means r squared is equal to 1/2 times by natural log of 36 squared, and therefore for the equation of c we have x squared plus y plus natural log 9 squared equals 1/2 times natural log 36 all squared. Here is the equation of c. Question number 3. For the first part of part A, we have to write down the binomial series expansion of 1 plus 2 over n to the n, where n is a natural number and n is greater than 2. And we have to do this in powers of 2 over n up to and including the term in 2 over n to the power of 3. So for part A, we have 1 plus 2 over n to the power of n, and that's equal to 1 plus n over 1 factorial multiplied by 2 over n plus n multiplied by n minus 1 divided by 2 factorial multiplied by 2 over n squared plus n multiplied by n minus 1 multiplied by n minus 2 divided by 3 factorial multiplied by 2 over n cubed. And then we've got higher order terms too. So now let's attempt to simplify this. We have 1 plus n multiplied by 2 over n plus n multiplied by n minus 1 divided by 2 multiplied by 2 over n squared, and then we have n multiplied by n minus 1 multiplied by n minus 2 divided by 6 multiplied by 2 over n cubed plus higher order terms. Now, hence prove that for n being a natural number and n being greater or equal to 3, 1 plus 2 over n to the n is greater or equal to 19 over 3 subtract 6 over n. So if we continue with the expansion, we have 1 plus, now here we have 2n over n, which is just 2, and then here we would have n multiplied by n minus 1 over 2 multiplied by 4 over n squared. And if we simplify this, well, here we've got n squared, subtract 3n plus 2, and then I'm multiplying that by n. So I've got n multiplied by n squared, subtract 3n plus 2, and then I'm going to divide this by 6, and then multiply this by 2 over n cubed, which is the same as multiplying by 8 over n cubed. So, if we attempt to simplify this even further, well, what we have here is 1 plus 2, which is 3, and then I'm adding on, well, here I've got n divided by n squared. That's going to give 1 over n, and the 4 over the 2 gives 2, so we end up with 2 multiplied by n minus 1 divided by n, and then here n divided by n cubed is 1 over n squared. 8 over 6 is 4 over 3. So we add on 4 multiplied by n squared, subtract 3n, plus 2, divided by 3n squared, and then we have higher order terms. So let's simplify this even further by expanding. We have 3 plus 2n over n, subtract 2 over n, plus 4n squared divided by 3n squared, subtract 12n over 3n squared, plus 8 divided by 3n squared, plus higher order terms. So we've got 3 plus 2, subtract 2 over n, and here we have 4 over 3, subtract 4 over n, plus 8 over 3n squared, plus higher order terms. And now we need to simplify all this. Well, 5 plus 4 over 3, that's the same as 15 over 3 plus 4 over 3, which is equal to 19 over 3. Then we have negative 2 over n, subtract 4 over n, so that's negative 6 over n, and then we add on 8 over 3n squared, plus higher order terms. Now we need to make a note here. When n is greater or equal to 3, 8 over 3n squared becomes non-negative and really small, and 1 plus 2 over n to the n increases quickly. And so what we can conclude from this then is the 1 plus the 2 over n to the n would be greater or equal to 19 over 3 subtract 6 over n, because this term increases quickly and the other terms here become small and non-negative. And that's exactly what we wanted to show. For part B of the question, we have to use the binomial series expansion of 1 minus x over 4 to the 1/2 to show that root 3 is less than 7 over 4. So, for part B of the question, we have 1 subtract x over 4 raised to the 1/2, and if I use the binomial expansion, we've got 1 plus, then here we've got 1/2 divided by 1 factorial multiplied by minus x over 4. So that's our second term. And then for our next term, we have 1 over 2 multiplied by 1 over 2 subtract 1, and then we divide this by 2 factorial and then multiply this by minus x over 4 squared. And then for our next term, we have 1 over 2 multiplied by 1 over 2 subtract 1 multiplied by 1 over 2 subtract 2 divided by 3 factorial multiplied by minus x over 4 cubed. So we have here 1 plus 1/2 multiplied by minus x over 4 plus, now here we've got a half times minus a half, so that's minus 1/4, and then I'm dividing that by 2, so that is minus 1/8, and then I'm multiplying this by minus x cubed over 4 cubed, which is, rather, I've got x squared over 16. And then for the next term, we have a half times by negative a half, so that's negative 1/4, and then I've got a half subtract 2, so that's negative 3 over 2, so I've got negative 3 over 2 multiplied by negative 1/4, so that's negative 3/8, so I've got positive 3/8, and then I'm dividing that by 6, so that's positive 1 over 16, and then I'm multiplying this by minus x cubed over 4 cubed, which is 64, and then I've got higher order terms. So I've got 1 subtract x over 8, and then I've got negative x squared over 128, and then I've got negative x cubed over 1024, and then I've got higher order terms with it. Now, if we go back to the question, we want to show that root 3 is less than 7 over 4. Now, we've got an inequality symbol here, and the way we can apply an inequality symbol is to think to ourselves, well, if here I've got a root 3, and if here I've got a 7 over 4, well, if I somehow remove these terms, then 1 subtract x over 8, we want that to look like a 7 over 4 somehow, and on the other side we want a root 3 somewhere, and I can think to myself, well, 1 subtract a quarter, that gives 3/4, and 1 subtract an eighth, that gives 7 over 8. So they do look familiar when x is 1. Now, before we do anything else, we can see that the expansion is valid for the mod of negative x over 4 being less than 1. In other words, the mod of x is less than 4. And because we've got some sort of an inequality, and think about the direction of the inequality that's used, what we can say here then is 1 subtract x over 4 to the 1/2 is less than 1 subtract x over 8. And the reason for that is because we want this result to help us to show this result here, which is why I've got this inequality. But the other reason why this inequality works is removing all the negative terms from the right hand side makes this side large. So I've simply removed the negative terms here, and by removing them, the 1 minus x over 8 will be greater than the expansion of 1 minus x over 4 to the 1/2. Now, if we substitute in x equals 1, we have 1 minus 1/4 to the 1/2 being less than 1 subtract 1/8. So we have 3/4 to the 1/2 being less than 7/8. The result here is looking familiar to what we want to show. Now 3/4 to the 1/2, that's going to be the same as root 3 over 2, and that's going to be less than 7 over 8. And if I multiply through by root 3, rather if I multiply through by 2, then we can say that root 3 will be less than 7 over 4. And that's exactly what we wanted to show. Now for part C, we're given that f of x is equal to 1 plus 2 over x to the x, subtract 3 to the power of x over 6. X is a real number where x is greater than 0. And given that the function f of x is continuous, and that the 6th root of root 3 is greater than 6 over 5, we have to prove that f of x equals 0 has a root in the interval 9 to 10. So, for part C of the question, we are given that f of x is equal to 1 plus 2 over x to the x, subtract 3 to the x over 6. And if we substitute in x equals 9, then we've got 1 plus 2 over 9 to the 9, subtract 3 to the 9 over 6. And if we work this out, we have 1 plus 2 over 9 to the 9, subtract, now here we've got 3 to the 3 over 2, which is the same as root 3 cubed. So we have 1 plus 2 over 9 to the 9, subtract 3 times by root 3. Now, what we want to do in this question is use a change in sign method. So, if we use our answer to what we found earlier, over here, we already know that 1 plus 2 over n to the n is greater than 19 over 3, subtract 6 over n. So, let's write that down. What we know is 1 plus 2 over 9 to the 9 is greater or equal to 19 over 3 subtract 6 over 9. In other words, one plus 2 over 9 to the 9 is greater or equal to 17 over 3. And if we think about what root 3 is in terms of what we've just found, well, we've just shown that root 3 is less than 7 over 4. So we also know that root 3 is less than 7 over 4, which would imply, if I multiply both sides by 3 root 3 is less than 21 over 4. And let's just multiply both sides by -1. -3 root 3 then will be greater than -21 over 4. So if we think about what we have here, then we have f of 9, which we know is equal to 1 plus 2 over 9 to the 9 subtract 3 root 3. This result here, well, we know that this over here is greater than 17 over 3, and then we are subtracting something which is greater than 21 over 4. So with that idea, then what we have is 17 over 3 subtract 21 over 4. Well, if we try to simplify this, well, we've got 1 plus 2 over 9 to the 9 subtract 3 root 3. This will be greater or equal than 17 multiplied by 4 subtract 21 times by 3 divided by 12. So we've got 1 plus 2 over 9 to the 9 being greater, subtract 3 root 3. This will be greater or equal than 5 over 12. So therefore, we see that f of 9 is greater than 0. So now what we need to somehow do is show that f of 10 is going to be negative. So if we work out what f of 10 is, we've got 1 plus 2 over 10 to the 10 subtract 3 to the power of 10 over 6. And now what we need to do is evaluate this. And to help us evaluate it, what we were told in the question is that the 6th root of root 3 is greater than 6 over 5. So let's see how we can achieve that. Well, given what we know already, what we have is 1 plus 2 tenths, which is equal to 6 over 5. So we have 6 over 5 to the 10, subtract. Now here I've got 3 to the power of 10 over 6 So that is the same as the 6th root of 3 to the 10. And if we use what we were told in the question, we know that the 6th root of 3 is greater than 6 over 5, which would mean that if I raise both of these to the 10, the 6th root of 3 to the 10 will be greater than 6 over 5 to the 10. And over here, this works because x to the 10 is an increasing function. So if we think about what we have over here, well, 6 over 5 to the 10, that is smaller than this result here, which means that f of 10 will be less than 0. We've got a smaller number take away a bigger number which is less than 0. And therefore we see that f of 9 is greater than 0 and f of 10 is less than 0. So as f of x changes size on the interval 9 to 10 and it's a continuous function, we can conclude there is a root in the interval 9 to 10. Question number 4. Figure 2 shows a sketch of the parabola with equation y equals 1/2 x multiplied by 10 minus x, where x is in between 0 and 10. This question concerns rectangles that lie under the parabola in the first quadrant. The bottom edge of each rectangle lies along the x-axis and the top left vertex lies on the parabola. Some examples are shown in figure 2. So here is an example of a rectangle, and here and here. These lie under the parabola. Now, if we let the x-coordinate of the top left vertex be a, we have to explain why the width w of such a rectangle must satisfy w is less than or equal to 10 minus 2a. Well, first of all, the parabola is symmetrical about the line x equals 5. So that's what we see here. And we know that the rectangle must lie under the parabola. So the rectangle must lie under the parabola. So the maximum width will occur when the top right vertex also lies on the parabola. An example of that is this parabola over here. Now, what we can do is write down the coordinates of the top left vertex and the top right vertex. Well, we are told in the question the top left vertex has an x-coordinate of a. So this point here is a. And the corresponding y-coordinate, if I substitute in a for x, the corresponding y-coordinate will be 1/2 a multiplied by 10 minus a. Now, if I think about what the coordinate of this point will be, well, the x-coordinate of the top right vertex, that will be, through symmetry, 10 subtract a. So if we're going A this way, we must go A this way. So the x coordinate of the top right vertex will be 10 minus A. And the y coordinate, that will be a half A times by 10 minus A. It lies on this line. And so the width of the rectangle, that will be, well, here is the width, and to work out the width, I've got this entire length, which is 10, and then I need to subtract the A over here and also over here. So I've got W being less than or equal to 10 subtract A subtract another A. And hence we can conclude that W is less than or equal to 10 subtract 2A. For part B, we have to find the value of A that gives the maximum area for such a rectangle. Now the maximum area must occur for a full width of a rectangle. In other words, that means W is equal to 10 subtract 2A. Now, the maximum area A, that will equal 1/2 times A times 10 minus A. So that is this height over here, and we times it by the width, and the width we know is 10 minus 2A. So if we work out what the maximum area is, we've got 1/2 A multiplied by 100 subtract 30A plus 2A squared. So if we work all of this out, we would end up with A cubed minus 15A squared plus 50A. And because we want to find the value of A for which we have a maximum, we need to differentiate. So if we have dA over dA, we can work out what this is. We have 3A squared subtract 30A plus 50. And if we now set this equal to 0, 3A squared subtract 30A plus 50 equals 0. And if we complete the square, we have 3 multiplied by A squared subtract 10A plus 50 equals 0. Now completing the square of this, we have 3 multiplied by, well, here I have A subtract 5 all squared subtract 25 equals 0. So A minus 5 squared equals 25 over 3. What we can therefore conclude, if we square root and add 5 to both sides, a is equal to 5 plus minus 5 over the square root of 3. Now, as a is in between 0 and 5, and that's because we need the valid rectangle and the area 0 at either end of this interval, we can conclude the maximum area occurs when a is equal to 5 subtract 5 over the square root of 3. Now, given that the rectangle must be a square, we have to find the value of a that gives the maximum area for such a square. Now, in other words, the length must equal the width. So, for a square, we have 10 subtract 2a equals a half a times by 10 subtract 2a. So we have 20 subtract 4a equals 10a subtract a squared. And if we rearrange, we would have a squared subtract 14a plus 20 equals 0. So a subtract 7 all squared subtract 49 plus 20 equals 0. A subtract 7 squared is equal to 29, which means a is equal to 7 plus minus root 29. And as a is in between 0 and 5, and also root 29 is less than 7, we can therefore conclude a is equal to 7 subtract root 29. Now for part D, given that the area of the rectangle is fixed as 36, we have to find the range of possible values for a. So for part D, if the area is 36, then W is equal to 36, the area, divided by 1/2 a multiplied by 10 subtract a. And if I multiply top and bottom by 2, we end up with 72 over a multiplied by 10 minus a. Now, we know that W is less than or equal to 10 subtract 2a. And if that's the case, then we can say that 72 divided by a multiplied by 10 minus a, that's what W is, this will be less than or equal to 10 subtract 2a. So we have 72 being less than or equal to a multiplied by 10 minus a multiplied by 10 minus 2a So 72 is less than or equal to A multiplied by 100, subtract, oh here we've got 40 minus another 10, so that's minus 50 A plus 2A squared. And therefore, if we attempt to simplify this even further, rather here we've got minus 30. We have 72 being less than or equal to A multiplied by 100, so that's 100A, then I've got subtract 30A squared plus 2A cubed. 2A cubed subtract 30A squared plus 100A subtract 72 is greater or equal to 0, and if I divide through by 2, A cubed subtract 15A squared plus 50A subtract 36 is greater or equal to 0. Now we need to find the critical values. So for us to find the critical values, we need to somehow factorize this cubic. So if we let f of a equal a cubed subtract 15a squared plus 50a subtract 36, then the factors of the 36, we've got plus minus 1, 36, 2, 18, 3, 12, 4, 9, and 6. So here are the factors of 36. So what we'll do is we will try f of 1. And if we get 0, that means a minus 1 is a factor of f of a. So trying f of 1, we've got 1 cubed subtract 15 multiplied by 1 squared plus 50 multiplied by 1 subtract 36, and it turns out here we get 1 minus 15 plus 50 minus 36, which is 0. And so we can conclude that a minus 1 is a factor of f of a. So if that's the case, we have a minus 1 multiplied by a squared plus two constants, rather plus an a term plus a constant term, will equal a cubed subtract 15a squared plus 50a subtract 36. Well, 1 times by 36 gives negative 36. And if I do minus 1 times a squared, I get minus a squared. I want a minus 15a squared, so that means I need to take away another 14a. So I've got a squared minus 14a plus 36 is equivalent to a cubed subtract 15a squared plus 50a minus 36. So therefore, if I solve f of a equal to 0, what I'm solving is a minus 1 multiplied by a squared subtract 14a plus 36 equals 0. So therefore, for my critical values, I've got a equals 1, rather if I attempt to factorize it first, rather if I attempt to complete the square, I've got a minus 1 multiplied by a minus 7 squared subtract 49 plus 36 equals 0. So I've got a minus 1 multiplied by a minus 7 squared subtract 13 equals 0, which means that my critical values, I've got a equals 1 and a equals 7 plus minus square root 13. So what I'm doing is I'm solving the inequality a cubed subtract 15a squared plus 50a subtract 36 being greater than 0. Now, if I draw a quick sketch of this curve, what I have is f of a here, and I've got my critical values. Here I'd have 1, here I would have the 7 minus root 13, and here I would have the 7 plus root 13. And therefore, what we need to do is find out where the graph is greater than 0, and it's greater than 0 here and in between here. So we have our inequality solution, 1 being less than or equal to a, and here we've got being less than or equal to 7 minus root 13, and we also have a being greater or equal to 7 plus root 13. And again, as a is in between 0 and 5, our solution will be 1, which is less than or equal to a, which is less than or equal to 7 minus root 13. Question number 5 for part A. The box below shows a student's attempt to prove the following identity for a being greater than b being greater than 0. We've got the arctan of a subtract the arctan of b is equivalent to the arctan of a minus b over 1 plus ab. The first thing they did was they let x equal the arctan of a and y equal the arctan of b, so that a is equal to tan x and b is equal to tan y. And so taking the tangent of both sides, well, on the left hand side we've got the tan of the arctan of a subtract the arctan of b being equivalent to tan of x minus y, and that's because x is arctan a and y is arctan b, so that's why the x minus y comes from in the bracket. And then they've used the identity for tan incorrectly, by the way. They've written tan x subtract tan y over 1 minus tan squared xy, and then recognizing that tan x is A and tan y is B. They've replaced tan x with A, tan y with B, and on the bottom they've got 1 minus AB all squared. And then they've rewritten the top, so they've got A minus AB plus AB minus B. The minus AB and the plus AB gives a 0 pair, and on the bottom it looks like they've factorised 1 minus and then in brackets AB squared as a difference of two squares. And then they've factorised, so they've got A multiplied by 1 minus AB, now that bit's incorrect, and then they've got minus B multiplied by 1 minus AB, and then on the bottom they've still got the 1 minus AB times the 1 plus AB. Now the 1 minus AB's cancel, leaving them with A minus B over 1 plus AB, and taking the arctan of both sides gives arctan A minus arctan B is equivalent to arctan of A minus B over 1 plus AB as required. There are 3 errors in this proof where the working does not follow the previous line. We have to describe the 3 errors. Well, first of all, the expansion of tan of x minus y is incorrect between lines 2 and 3. Going back, what we should have, well, for the denominator it should be 1 plus tan x times tan y, not the minus. The next thing that's wrong is in between lines 3 and 4. They've got tan squared xy, and what they've done is they've assumed that tan xy all squared is tan x tan y all squared between here and here. So the next thing that's wrong is between lines 3 and 4, when replacing the tangents, tan squared xy is not AB all squared. The student has incorrectly assumed that tan x y all squared is equal to tan x times tan y all squared, which is not the case. And the third thing that's wrong is the factorization between here and here. So the factorization between lines 5 and 6 is incorrect. A minus AB is equivalent to A multiplied by 1 minus B, not A multiplied by 1 minus AB. So those are the things that's wrong. And then we have to write out a correct proof for the identity. Now, ultimately we want to show this over here. So what we will do is we will let x equal the inverse tan of A, and we will let y equal the inverse tangent of B. And if that's the case, then tan x is equal to A and tan y is equal to B. So from this, we would have the tangent of the inverse tan of A subtract the inverse tangent of B equaling the tangent of x minus y, and using the identity, this is the same as tan x subtract tan y divided by 1 plus tan x times tan y. And using what we know about A equaling tan x and B equaling tan y, this is the same as A minus B divided by 1 plus AB. And so what we can now do is take the tangent of both sides, rather if we take the arctangent of both sides, if I take the arctangent of the tan of something, then that will just be something. So therefore, taking the arctangent of the tangent of this here, that will just give the inverse tan of A subtract the inverse tan of B, and that will equal the inverse tangent of A minus B over 1 plus AB. For part B of the question, now we have to take g to be 9.8 meters per second squared, and balls are projected one after another from a point A 1 meter above horizontal ground. Each ball travels in a vertical plane towards a 6 meter high vertical wall of negligible thickness, which is a horizontal distance of 10.10 root 2 meters from A. Now let's add this to the diagram as we see here. The balls are modelled as particles, and it is assumed that there is no air resistance. Each ball is projected with an initial speed of 28 meters per second at a random angle theta to the horizontal, where theta is in between 0 and 90 degrees. And given that a ball will pass over the wall precisely when alpha is less than or equal to theta, which is less than or equal to beta, we have to find in degrees the angle beta minus alpha. Now, if we find the horizontal distance, Sx, that's equal to 28 multiplied by cos theta multiplied by t. And we know what the horizontal distance is, that's 10 root 2. So we have 10 root 2 equals 28 cos theta multiplied by t. And so therefore, t is equal to 10 multiplied by root 2 divided by 28 cos theta. Let's now consider the vertical motion. We have Sy equals 28 sine theta multiplied by t minus 1/2 g, so that will be 4.9 t squared. Let's leave this actually as 1/2. So here we've got 1/2 g t squared. And this is relative to the point A, as we see in this diagram. So we're taking A to be the 0 level. Now, it will pass over the wall when the displacement is greater than 5. So from A to the top of the wall, that's 5 meters. It will pass over the wall when it's greater than 5 meters. So we have the condition Sy being greater than 5, and so we have 28 sine theta multiplied by t minus 1/2 gt squared is greater than 5. And what we will do is substitute in our t into here. So we have 28 sine theta multiplied by 10 root 2 divided by 28 cos theta, and then we subtract 1/2 g multiplied by 10 root 2 over 28 cos theta squared. This is greater than 5. So now we need to tidy all this up. Now here the 28 and the 28 simplify to 1. And then we have sine theta over cos theta multiplied by 10 root 2 subtract 9.8 over 2 multiplied by, well here 10 root 2 all squared is 200, and then we have 28 squared, which I'm going to write as 28 times 28, and we'll multiply this by 1 over cos squared theta. This is greater than 5. So let's try to simplify as much as we can. So if we try to simplify, we have 10 root 2 tan theta subtract, now here we've got 9.8 over 2, which is 4.9, and this 4.9 I'm going to rewrite as 49 over 10, and I'm going to multiply this by 200 over 28 times 28. I can divide the top and bottom by a value of 2, so that will leave 100 over, well, think about it, I would have, if I just write it out outside, I've got 200 divided by 28 times 28, which is the same as 100 divided by 14 times 28, divide top and bottom by 4, so I would end up with 25 over 14 times by 7, which is 25 over 98. So we have 25 over 98, and I'm going to multiply this by sec squared theta. The result is greater than 5. Now let's see what we can simplify here. Now the 49 over 10 times by 25 over 98, this cancels with this twice, so I'm left with 25 over 20, which would simplify to 5 over 4. So we have 10 root 2 tan theta subtract 5 over 4 sec squared theta is greater than 5. And what we can do is divide every term by 5 and then times by 4. So if I divide through by 5, I would end up with 2 root 2 tan theta subtract 1/4 sec squared theta being greater than 1 times through by 4. So we have 8 root 2 tan theta subtract sec squared theta being greater than 4. And sec squared I can replace with tan squared plus 1. So we have 8 root 2 multiplied by tan theta subtract 1 plus tan theta squared is greater than 4. And if we simplify, what we will end up with, if we take everything over to the other side, we would end up with tan squared theta subtract 8 root 2 tan theta plus 5 being greater than 0. Now we need to solve this inequality to find the range of values of theta. So, if we complete the square, we've got tan theta subtract 4 root 2 all squared, subtract the square of 4 root 2, which is 32. Then we add 5. This is greater than 0. So, we have tan theta subtract 4 root 2 squared being greater than 27. And so what we will end up with for our critical values is tan theta equals 4 root 2 plus minus the square root of 27, which is 3 root 3. And what we need to do is find out beta minus alpha. So if we work out beta minus alpha, well, what we can do is use the result over here. That will equal the arctangent of the result shown here. So to work that out, what we will have for beta minus alpha is the inverse tangent. So we have the inverse tangent of 4 root 2 plus 3 root 3 subtract 4 root 2 subtract 3 root 3. And then I'm going to divide this by 1 plus 4 root 2 plus 3 root 3 multiplied by 4 root 2 subtract 3 root 3. So we've got the inverse tangent of, now on the bottom I've got a difference of 2 squares. I've got 1 plus this difference, 4 root 2 times 4 root 2, that's 16 times 2, which is 32. And then 3 root 3 times minus 3 root 3, that's minus 27, so that's what I have on the bottom. And on the top I've got 4 root 2 subtract 4 root 2, that's 0 root 2, 3 root 3 subtract negative 3 root 3, that will be 6 root 3. So I've got the inverse tangent of 6 root 3 divided by 6. So I've got the inverse tangent of root 3, which is just 60 degrees. Now for the next part, we have to deduce that the probability that a particular ball will pass over the wall is 2/3. The probability that every given ball successfully clears the wall is given by P equals 60 degrees divided by 90 degrees, which is 2/3. For the third part, hence find the probability that exactly 2 of the first 10 balls projected pass over the wall. You should give your answer in the form P over Q to the K, where P, Q and K are integers and P is not a multiple of Q. If we let the random variable x equal the number of balls passing over the wall out of 10 attempts, what we can say then is we are looking at a binomial with parameters 10 and probability 2/3. So the probability that x is equal to 2, that will equal 10 choose 2 multiplied by 2/3 squared multiplied by 1/3 to the 8. So now we need to simplify all this. Now 10 choose 2, that will be given by 10 factorial divided by 2 factorial multiplied by 10 minus 2 factorial. And I'm going to multiply this by 2/3 squared multiplied by 1/3 to the 8. So let's see if we can simplify this even further. 10 factorial is the same as 10 times 9 times 8 factorial, and then I'm going to divide this by 2 factorial multiplied by 8 factorial. 10 subtract 2 factorial is 8 factorial. And then 2/3 all squared, that's 4 over 9. And then I've got 1/3 to the 8, so that is 1 over 3 to the 8. So now let's try to simplify this. Well, the 8 factorials cancel, so I've got 10 times 9 over 2. So let's just write this out as 10 times 9 times by 4 times by, well, it's times by 1. And I'm going to divide this by 2 times by, now here I've got a 9, and then I've got a 3 to the 8. So the 9's cancel. 10 times 4 over 2 is 20. So I've got 20 divided by 3 to the 8. This is our required probability. For the fourth part, we have to explain whether taking air resistance into account would increase or decrease the probability in the third part of part B. Well, taking air resistance into account would decrease the range, so the probability of success would be reduced, so the probability of 2 successes would increase. Question number 6. For part A, given that f is a function such that the integrals exist, we have to use the substitution u equals a minus x to show that the integral from 0 to a of f of x with respect to x between 0 and a is equal to the integral of f of a minus x with respect to x between 0 and a. So for the first part of part A, we have u equals a minus x, and if I rearrange for x, we can see x is equal to a minus u. And so if we differentiate, we can see that dx over du equals minus 1. So therefore, dx is equal to minus du. And so, you can see, when x is equal to 0, u is equal to a minus 0, which is just a, and when x is equal to a, u is equal to a minus a, which is 0. And so therefore, the integral from 0 to a of f of x with respect to x, this would transform to the integral of, well, instead of 0, I'm going to have a, and instead of a, I'm going to have 0, and then the x we can replace with a minus u, so I'll have f of a minus u multiplied by negative du. And what this is equivalent to is the integral from 0 to a of f of a minus u du. Now here, as it is a definite integral, you can use any variable you like. It's going to give you an answer in terms of a, and that number is the same for whatever you call the variable. So whether I have a u in this integral and I get some answer, or whether I have a t or whether I have an x, it doesn't make a difference, because I've got a definite integral. Whatever variable I use, my answer will be the same in terms of a. And so therefore, we replace u with x. And if we replace u with x, we can therefore conclude that the integral from 0 to a of f of x with respect to x will equal the integral from 0 to a of f of a minus x with respect to x. Now we have to use symmetry of f of sine x on the interval 0 to pi to show that the integral from 0 to pi of x times f of sine x with respect to x is equal to pi multiplied by the integral from 0 to pi over 2 of f of sine x with respect to x. Now what we need to do is use the idea here. We've got some function involving x. In this case, it's x times by f of sine x. And what we can do then, noting that from what we worked out previously over here, we can replace the x with a minus x, where a is equal to pi. So For the second part of our question, we are integrating from 0 to pi x multiplied by f of sine x with respect to x. And this is the same as integrating from 0 to pi. Now I'm going to replace the x with a minus x, where a is pi. So I'm going to have pi minus x multiplied by f of the sine of pi minus x dx. So if let's just write this out again. We've got the integral from 0 to pi of x times by f of sine x dx. This is equal to, now if I expand out, I've got the integral from 0 to pi of pi times by f of sine of pi minus x and then we subtract the integral from 0 to pi of x times by f of sine of pi minus x dx. And now what we can do is use the fact that sine x is equivalent to the sine of pi minus x for all x belonging to real numbers, and therefore what we will have is, on the left hand side, that will remain the same, the integral from 0 to pi of x times by f of sine x. On the right hand side we have the integral from 0 to pi of pi times by f of sine x dx. Because I've replaced the sine of pi minus x with just sine x, subtract integral from 0 to pi of x times by f of sine of pi minus x dx. So what we can now do is add. We can take this over to the left hand side, which will result in 2 times by the integral from 0 to pi of x times by f of sine x dx, which is equal to the integral from 0 to pi of pi times by f of sine x dx. Now, what we also know, f of sine x is symmetric about the line with equation x equals pi over 2 on the interval 0 to pi. So because of symmetry, what we can then say is 2 times the integral from 0 to pi of x times by f of sine x with respect to x is equal to 2 times by the integral from 0 to pi over 2 of pi times by f of sine x dx. And if we divide through by 2, We can therefore conclude the integral from 0 to pi of x times f of sine x with respect to x is equal to the integral from 0 to pi over 2 of pi times by f of sine x dx. For part B of the question, we have to use the result from the first part of part A to show that the integral from 0 to pi over 2 of sine x to the n over sine x to the n plus cos x to the n with respect to x is independent of n, and we have to find the value of this integral. Well, for this part of the question, we want to show that this integral is equal to some value a, some constant, and that also this integral, because it's equal to some constant, is independent of n. Now, if we use the result from part A, this integral we can replace the x with, using what we found from the first part of part A, we can replace the x with a minus x, where over here a is equal to pi over 2, and so doing so, we've got the integral shown here. X has been replaced with pi over 2 minus x. So we've got the integral of sine of pi over 2 minus x to the n over sine of pi over 2 minus x to the n plus cos of pi over 2 minus x to the n with respect to x. I'm integrating from 0 to pi over 2. Now, the way we can simplify this, well, the left hand side is going to remain the same, but on the right hand side, the sine of pi over 2 minus x, that's the cos of x, and the cosine of pi over 2 minus x, that's just sine x. So on the right hand side we end up with this result here. We've got the integral from 0 to pi over 2 of cos x to the n over cos x to the n plus sine x to the n, all being integrated with respect to x. And now, because of commutativity, we can swap the sine x and the cos x on the right hand side, as we see here. So this is just applying the commutativity laws. Now, what we want to do is find a result for this over here. And the way we can do that is to think to ourselves, well, the denominators here are the same, and we want to get some sort of a constant. And the way we can approach that is, if I add this to both the left hand side and the right hand side, well, we've got this bit plus another one of these, and that's going to equal what we have over here on the right hand side, and then I'm going to add on, to maintain equality, this over here. And the reason I want to do that, well, first of all, on the left hand side I've got twice this integral, but on the right hand side I've got cos x to the n plus sine x to the n over sine x to the n plus cos x to the n. We've got this common denominator of sine x to the n plus cos x to the n. And so what we have then is the integral of 1 on the right hand side between 0 and pi over 2. So dividing through by 2, we end up with 1/2 times the integral of 1 with respect to x between 0 and pi over 2. And so working this out, we end up with 1/2 times 1/2 multiplied by x evaluated between pi over 2 and 0. So I've got 1/2 times by pi over 2 minus 1/2 of 0, and therefore the integral from 0 to pi over 2 of sine x to the n over sine x to the n plus cos x to the n is pi over 4 for any value of n. And that's exactly what we wanted to show. Now for part C, for the first part, we have to prove that cos x over 1 plus cos x is equivalent to 1 minus 1/2 times by sec squared of x over 2. So for the first part of part C, we've got cos x over 1 plus cos x. So now let's try to get to the right hand side. The cos x we can rewrite as 1 plus cos x minus 1. On the bottom we still have the 1 plus cos x. And therefore we can rewrite this as 1 plus cos x over 1 plus cos x minus 1 over 1 plus cos x. In other words, we've got 1 minus 1 over 1 plus cos x. And if we think about what we want to show that we've got sec squared of x over 2 somewhere. And the way we can do that is as follows. Well, we've still got this 1 and then we've got the minus. In the denominator here we've got 1 plus, and the cos x I'm going to replace with 2 times by the cosine of x over 2 squared minus 1. And then here I've got the 1. So the 1 and the minus 1 simplify to 0. So I've got 1 minus 1 over 2 times by cos squared of x over 2. So I've got 1 minus 1 half times by sec squared of x upon 2, which is equivalent to the right hand side, hence shown. For the second part, we have to use the results from part A to find the integral from 0 to pi of x times by sine x over 1 plus sine x with respect to x. Now, from the second part of part A, we saw that integrating from 0 to pi of x times by f of sine x with respect to x is equal to pi times the integral from 0 to pi over 2 of f of sine x with respect to x. Now, here we've got an x, and here we've also got an x, and f of sine x, that's sine x over 1 plus sine x, and we're integrating from 0 to pi. So we can apply the result from the second part of part A. So, using the second part of part A, we've got the integral from 0 to pi of x sine x over 1 plus sine x with respect to x. That's equal to pi times by the integral from 0 to pi over 2 of sine x over 1 plus sine x. And now if we use the next part from the first part, we know that integrating f of x from 0 to a, that's the same as integrating from 0 to a f of a minus x, where essentially over here we're going to be replacing the x with pi over 2 minus x. So this integral is equal to pi times by the integral from 0 to pi over 2 of sine of pi over 2 minus x over 1 plus sine of pi over 2 minus x with respect to x. Now the reason I want to do this is I can recognize that the sine of pi over 2 minus x is cos x, and what I'll end up with is cos x over 1 plus cos x, which I can integrate by using this result here. So this integral is equal to this result here, and replacing the sine of pi over 2 minus x with cos x, we end up with pi times by the integral from 0 to pi over 2 of cos x over 1 plus cos x with respect to x. Now we can apply what we found in the first part of part C. This is the same as integrating between 0 and pi over 2, 1 minus a half sec squared of x upon 2, then multiply the result by pi. So if we integrate, we end up with pi multiplied by x minus the tan of x upon 2 between 0 and pi over 2, and if we substitute in for our upper limit, we get pi multiplied by pi over 2 minus the tan of pi over 4. For the lower limit, we just get 0. And this simplifies to pi multiplied by pi over 2 minus 1, which is pi squared minus pi. Now we have to find for part D the integral of x times by sin x to the 4 over sin x to the 4 plus cos x to the 4 with respect to x between 0 and pi. Now, for this part, we want to get the integral in terms of sin x only to apply previous known results. So we've got our integral over here. And for us to write this in terms of sin x only, well, the cos x to the 4, I can rewrite as cos x squared squared. And I know that cos squared x is 1 minus sin squared. So I replace the cos x squared with 1 minus sin x squared. And now we can apply previous known results. What I can do over here is apply the second part of part A. I've got x times by a function of x with respect to x integrated between 0 and pi, that's what I'm doing. That's equal to pi times by f of sin x with respect to x between 0 and pi over 2. So, using the second part of part A, we end up with this result here. And now, if we think about what we showed previously over here, if I have sin x to the n over sin x to the n plus cos x to the n with respect to x between 0 and pi over 2, I know the result is pi over 4 for any value of n. So, if I replace the 1 minus sin squared with cos squared, as we see here, and then cos squared squared, that's cos to the 4, I've got here pi times by pi over 4. So this was using the result from the second part of part A. And therefore, we end up with pi squared over 4.